I actually changed the title of this presentation slightly over the last several months because it's been a long time since I actually submitted this presentation to the call for papers. So it is the same Istio-style presentation you came to see, including some introduction to Kubernetes kinds of things. So we're going to go ahead and get started. We only have a few minutes to spend with each other, and we have a lot of ground to cover. Now, I'm curious to know who here has actually put hands on Docker at this point. You've done some Docker stuff. Fantastic, okay, great. Most people know Docker, that's great. How many people have put hands on Kubernetes at this point? Oh, large Kubernetes crowd, fantastic. So this is kind of an advanced Kubernetes topic, meaning we do assume you feel comfortable with Kubernetes already, and we take you to the next level with something called Istio. And then tomorrow what I'll do is I'll talk a little bit about a technology called Knative, which is beyond Istio even. So all this is kind of bleeding edge technology. We'll see if I do a little bleeding here live on stage. My name is Burr Sutter. So it's a very unusual name, I know, for people who are like, is that a weird American name? No, it's just a weird name, period. Okay? It just really is. This is my first time in Malmö, Sweden. I thank you so much for inviting me up here. Øredev is obviously a beautiful, wonderful conference. You guys have a great thing going here in Malmö. I'm very impressed with what I see here, and I travel the globe looking at conferences everywhere, it seems like. So this is really fantastic stuff. And what we're going to be doing is digging into this thing called Istio, the service mesh technology. And the reason the title's changed just slightly, as you'll see in a second, I'm kind of on this Bruce Lee kick right now. Anybody remember Bruce Lee? Fantastic, okay? So this is where the title comes from. Make sure you get access to the slide deck at bit.ly/istio-intro. That'll get your hands on the deck because there's going to be a million other things you want from that deck. Okay? Just keep that in mind. There's going to be a bunch of other things. And as a matter of fact, I'm going to run a little Twitter-based raffle for a Chromebook I have here. I brought one for today, one for tomorrow. It doesn't have the box anymore because I've been lugging it in my luggage, all around Europe, things of that nature. I just recently came up from DevOps, Belgium, and then by way of Amsterdam, where I spent a lot of time with various Red Hat customers there. So I was just in DevOps, Belgium last week, so we gave away some Chromebooks there too. So if you are a Twitter user, feel free to follow, take a photo, and then, of course, send that out on Twitter, and then I just have a piece of software that randomly picks from those tweets and says, you're the winner. Okay? So remember that one. I often run this as a hands-on workshop that takes about 3 hours with the O'Reilly team, the Safari Live effort, so you could actually spend several hours trying this on your own. As a matter of fact, there's actually a great tutorial we offer with this technology, so you could spend 7 hours or more trying it, but we're not going to do that now. And this is really where the Bruce Lee thing came in, right? Enter the Dragon. You guys remember that movie? Fantastic. So that's where enter the service mesh. That's kind of the phrase I got from that also. So that's where this came into play. So let's actually talk about your journey to awesomeness. If you've seen one of my presentations before, you've seen this Twitter slide before. I've been using it now for many, many years, close to 20 years actually, I think. But I just change up the things that we're to be learning. Because here's the thing that's really important. We're always on this continuous journey to learn more things, understand more things, grow in our skill set. I've actually been programming since 1986, and so I've been thinking about that for a long period of time. And the beautiful thing about our chosen career path is that we're always learning. And in this case, you have to be thinking about DevOps a lot more than we have been lately. Because if you work for a large organization, maybe you work for a big bank or big insurance company or a big exporter or some other big government entity, we actually have created this concept where we have these DevOps teams where there are no devs on them. Have you guys seen that yourself? Right? What's happened is, just like when developers decide, senior developers declare themselves architects to get a raise, ops people have declared themselves DevOps in the same kind of way. And that's what I've seen throughout the industry right now. And so we just have to remember that. That is not what DevOps was all about. DevOps has dev also in the name, and developers should be part of that team. And you should be responsible for what you actually create. You should also be thinking about your self-service, on-demand elastic infrastructure. No longer should you be waiting 3 weeks to get a virtual machine, or 2 weeks, or even 2 hours, right? No vice president should sign off on a ticket so you can get access to a computer. That way should be gone, but yet I know it's pervasive in our industry still, right? Someone's manager has to agree that you get access to a computer, yet we're digital creation professionals. We should be getting access to computers very easily. All right, you should be thinking about automation. No longer feeding CDs or DVDs into trays anymore, and no longer SSH with yum install this and apt-get install that. okay? No more of that. It should be a fully automated script where we can burn the whole server to the ground and recreate it from scratch with a simple command, a single command. That's the world we should be living in now. So that's like your Ansible playbooks, maybe Puppet or Chef, or even a Bash shell script, okay? Be thinking about your CI/CD deployment pipeline. And we're also going to talk about advanced deployment techniques, and that's actually where we're going to focus today. So in other words, we're going to kind of skip through some of these early things and get you all the way over here to advanced deployment techniques and show you what you can do with a blue-green deployment, a canary deployment, what I call a smart canary deployment, even a dark canary deployment, or dark launch. And we're going to talk about some other things that are available to you now in this Istio world. But the goal of all this evolutionary journey, of course, is to be a unicorn. This is the GitHub unicorn. That's where I stole the image from. But you also want to be a pink, snarly unicorn with a rainbow mane. Isn't that awesome? Okay? And of course, all this stuff fits in this world of Kubernetes and OpenShift and Istio, and that's the world we're going to focus on. But then you can be like this unicorn. Right? He's totally awesome. So let's talk about your application very quickly, and I want to show you some demonstrations, and I don't want to run out of time. We don't have a lot of time today. But we know what our application looks like and feels like if we're an enterprise software developer. I've been doing Java-based software development since the late 90s. And so we knew how to build an app, right? Whether it was the early servlets or early EJBs with J2EE. We had these different roles, right? We knew exactly who the developer was versus the deployer versus the sysadmin, Linux administrator or Unix administrator back then. And we could get our arms around this application. So at least we knew what it was. And we refer to this now as the monolithic application. Right? If you're a Java person, you put your jars in your wars in your ear. You guys remember all that? I know I'm talking ancient history for most of you, right? Right? Because we no longer use WebSphere. We no longer use WebLogic. We no longer use JBoss. And actually, I came to Red Hat through the JBoss acquisition many, many years ago. So yeah, we don't use those things anymore. I'm kidding. We use a lot of those things still to run all the biggest businesses in the world. So we're still living in this world, but what we want to talk now about is how to be more cloud native. Okay? How do you be more microservice oriented, and how do you think about building applications to move rapidly? So if we look at our application, we start to break it down into these individual components or modules or subsystems, however you want to think of it. Hopefully not through OSGI necessarily, but some other mechanism to think about the components within that application. And over time, if we do our jobs well, that monolithic application kind of fades into the background, as you see here. As a matter of fact, we start to distribute it across a network of services. So in other words, this is where things get really weird for us in this microservice cloud native world. Right? We have introduced this network link between our components. And that's where things can go really crazy for us, okay? Now, the good news is, if in microservices we want to be deploying rapidly with our two-pizza team, so therefore everybody gets their own database, right? That's kind of cool, too. We get our own database. We don't have to deal with that centralized Oracle system anymore or a centralized DB2. If I want to use Mongo and lose my data, I can, right? That's cool, okay? We have multiple points of entry inside our application. So not only, in our old monolithic application, it was obvious. You went through our nice JSF user interface that we created. You would interact with our application. But now we're like these RESTful APIs that poke all out to the world at large, so our various business partners can interact with our back-end application. And then we, of course, think about these microservices principles. And there's a lot here. And almost nobody really wants to apply all these principles to their microservice. They just want to build something that's not a big old monolithic WebSphere app or WebLogic app, right? That's really what I see happening throughout the world at large. People are like, I'm doing microservices because I stuck it in a Docker container. Well, that's not exactly the definition, right? So there's a lot of principles you could adhere to your organization or adhere to your software development paradigm that you're going to be going through. But some of these are very, very hard. Right? Look at the governance aspects of these things. I don't want to have centralized governance anymore. I want to have decentralized governance. I want teams to be responsible for their actual workload and their application development, being responsible to their business unit, whomever they report to. As a matter of fact, we have to think in terms of being product-oriented, not project-oriented. We build these individual components in such a way that we can then deploy them in a really rapid way, but also we cannot break backward compatibility with our APIs. Okay, so there's all this kind of stuff that actually makes microservices very, very hard. But what I want to show you in this particular presentation is, assuming you can get over all these challenges, there's some pretty interesting things you can do in this new world. Okay? So let me get a quick recap of what it looks like to live in this Kubernetes world. Okay? So I'm going to just show you a couple things real fast. I was actually just looking at all my pods I'm running here. So many of you had some Kubernetes background already. You can see I have a bunch of pods. And a pod is nothing more than the computer, if you will, that my Java code thinks it's running on. Okay? The pod is the container, Linux container, but it's actually more than a single individual container. Let me do this real quickly. kubectl get pods. All right. You can kind of see right here, see how it says 2 by 2? Okay? By default, if you've dealt with Kubernetes, it's always 1 by 1. You've always seen that concept where we're basically 1 by 1, meaning one Linux container to one pod. That's how we've always thought of it. And some of you are probably thinking, why do we even call this a pod? Okay? Why not just call it a Linux container? And you can think of it as a Linux container, except for this one little trick, Docker logo. Okay? The Docker logo includes this concept of this little whale in a container ship, and a family of whales is a pod. Okay, so that's where the word pod comes from. The concept either like peas in a pod or simply a family of whales represents a pod. And you kind of see here I have two different things in my customer pod. So if I come over here and say kubectl describe pod and that name of that customer pod there, you can kind of see there's more to it than what I originally injected in it at this point. As a matter of fact, there's this thing called Istio that's been applied to it. Okay, the Istio Envoy sidecar, basically an Istio proxy, which has been applied to it. And then my little application code is simply right here. This is my Docker image right here, my example customer latest. So let's kind of just build something. Let's just kind of show you how we update something real quick. So if I do Docker images, grep example, if I type correctly, okay, you can see I have a customer, I have a preference, and a recommendation. As a matter of fact, customer calls preference, and preference calls recommendation, as you can see like that. So in a distributed computing way, right, we have 3 different microservices interacting with each other. So customer calls preference, preference calls recommendation. The nice thing is these can be individually scaled, right? These can be individually operated on. I can deploy one without negatively impacting the other, as long as I maintain backward compatibility across my API. These are simply using Jack's RS-style programming model, right? And in this case, Spring Boot for most of these things. And this actually is a Vertex application. It doesn't really matter. As long as you speak JSON over HTTP, anybody can interact with you, whether it be Python or Node.js or something of that nature. And you can kind of see here I have the name of the server listed right there. Let's go get pods again. The name of the server from a Java standpoint is actually the name of the pod. See that right here? Okay? So in other words, that is, in fact, the computer name that that application thinks it's running on, the host name that it thinks it's running on. So all of these things are actually running on 8080 and all running on my laptop. So if you're familiar with Java and Tomcat and use of those kind of technologies, everybody's running on 8080, which is kind of cool, because I can run 24 different JVMs if I want to, and actually the number is arbitrary. You can run 10, you can run 2, you can run 45, depends on how much memory you have. You can basically run all of those on 8080. But let's try this real quick. Let's just look at this little application. Let me bring up my Visual Studio Code. This is actually a Vertex endpoint, right? So don't worry about the programming model here. We're not here to teach you that. But the point is you can put anything you want into a Linux container, whether it be your C# application development if you're with .NET Core, Python, Perl, PHP, Ruby, Node. It doesn't really matter. Okay, so let's do this. Let's do Øredev v2. Make it a nicely different piece of string there, so make it obvious. We'll put v2 there, okay, on the logger. And so if I make a code change, I got to compile. And actually, let's just do this. Let's do clean package. All right, let's just do a quick compile of that thing. And actually, that can keep spinning along there. Let that go. Okay, and I now have a target directory. So this is my binary living here. So this is a fat jar deployment. So Vertex, like many things, and Wildfly Swarm or Thorntail or Spring Boot or Drop Wizard, they all give you this fat jar concept. So I can do this java-jar target and recommendation. So there it goes. It's up and running super fast. Okay, so I'm just interacting with it. There it is. You can see I basically get the v2 out of it right there, or the v2. So that is, in fact, what I want to go with. So let's go ahead and build my Docker image. And if we look right here, you can see there is, in fact, a Docker file. All right, so there's my Docker file. Relatively straightforward. It uses this base image. And of course, one of the biggest challenges with living in this new containerized world is figuring out what your base images are going to be. This is just one that I know that the Red Hat team has provided to the world at large, and so I use it. But you can pick anything you want there. No big deal there. Yeah, okay. Uh-huh. What's something cut off? Still blinking? Oh, still blinking. We got a blinker. Okay, we'll go down in size. It doesn't look like it'll go that far, go that low. How about interlaced? 50 hertz? That's even worse. But we have 50 hertz, but it doesn't allow us to go 720 right now. Well, what's the trick to get the additional ones? Let me see. There's a command for that. Yeah, all right, forget. I think that's going to be it. It's not 720. It's not even an option.
But 1080i was bad.
Yeah. Okay. We'll have to just let it blink a little bit. Okay. Example recommendation. I'm going to just do a Docker build here real quick. Actually, let's do this. Docker images. Let me see what. All right. Make sure I got. That's my Docker images. Make sure I'm connected to the right Docker daemon. I'm connected to the one running here in Minishift on my local machine. And I'm going to do a Docker build -t. Okay. And let's just call this example recommendation v2. All right, so that'll give me the next Docker image I need. And you can see there's a v1 now and a v2, right? You see that? So v2, v1. All right, we now have our second Docker image. And I can even do a docker run -it-p. Everyone here said you did Docker already, so this should be pretty straightforward. Okay, v2. And let's run that. Okay, and there it goes. It's up and running now. And let's see here. Double check my IP address. And let's actually stop this to save a little CPU cycle here. Come on, what is my IP address? I think it's 192.168. 199? No, 99. So 100. Yeah, okay, so let's do that. So there I'm interacting with the Docker instance that's running inside my Minishift, my Minikube environment here. So basically, again, I'm running this whole thing as a cloud on this laptop right now. So basically, I have the full Kubernetes environment living here. So there it is. I have that application running. And what I want to do next, let's do this, get pods. Okay, I'm going to just cheat and copy and paste a piece out of our tutorial out. As I mentioned, this thing's all documented in this big old tutorial that can take you several hours. So everything I'm showing you is already documented here. But what I'm going to do now is launch the thing into Kubernetes, right? So basically, I'm doing a Kubernetes deployment. And again, this is just all the kind of Kubernetes recap here. You can see there's a new version 2 coming online. See that it says 1 of 2. When it goes 2 of 2, it automatically gets thrown into the load balancer. And there it is. So now we have the 50/50 load balancing, basically, you get for free. And that's pretty standard stuff if you're familiar with how Kubernetes works. Basically, you get the load balancing, the service discovery, you get those things kind of out of the box. And now I have my little application running inside Kubernetes. Okay? At least the changed version that I've made. So we're going to actually have some more fun with this little application, but this kind of gives you a feel for what you're doing with what you're dealing with in a Kubernetes architecture. Now, what's super cool about this is because I've done it this way, and my application code again is kind of indifferent. It just works within a Linux container, meaning it knows Linux. That's it. I can now deploy this anywhere. So I actually have a bunch of these things running. They kind of show you this. I actually have an instance running on Amazon, an instance running on Azure, and an instance running on Google. So I can now deploy this across all those clouds very easily if that's what I chose to do. It looks like I need to log in over here. Looks like my login expired there. But we'll come back to some of this later maybe if we have time and let you look at some of these things. But I have a lot of different things I've already deployed across the public cloud. So I have both the local cloud running and 3 public clouds running. But the benefit to me is, as a developer, now that I know Kubernetes, I can pick those applications up and move them anywhere. Okay? And the programming model is, basically a standard thing from this point. Let's go ahead and shut that down and jump back over here real quick. And where did I put this thing? Yeah, over here. There we go. Okay. So a quick recap of that, and we got to keep moving along though. We don't have a lot of time. All right, so microservices are fundamentally about distributed computing. Customer calls preference, preference calls recommendation. You got to remember the fallacies of the network and distributed computing are going to bite you. Hopefully you know about this term before, right? The concept that the network is reliable when it's not. Bandwidth is never infinite. Latency is never 0. These things will burn you if you've put a network in between your application components. So if a failure of a service occurs across our service mesh, is it a cascading failure? Does it blow up the whole chain of services that are invoking it? And the one thing you really need to guard against is not actually a service outage. That's relatively easy to deal with a try-catch-finally block. If you're familiar with exception handling in Java, it's pretty easy to deal with the fact that a connection cannot be made. The problem is when a connection can be made, but the service still responds very, very slowly. Like if you've ever dealt with a database, which its indexes are all screwed up, and you do a full table scan of select splat from customer or whatever it might be, and it takes, let's say, 45 seconds for the database query to respond. The problem with that is the 45 seconds might be fine normally, but your SLA to your customer, remember, you're building a product and an API that you're exporting to the world, you might only have a 2-second SLA. And the 45 seconds of the database response could kill you, right? You've now blown your service level agreement. So you have to think about those kinds of things. There's a lot of key capabilities in the microservices arena that you should be considering as you deal with this new kind of application architecture. What's my discovery mechanism? What is my invocation technique? What is my elasticity model? Okay, what is my resiliency model? To kind of give you a feel for elasticity here, let's try this real quick. Let's go back over here. Looks like that guy's running. And actually, let's do this. Let's get pods. Let's just switch windows here to make it a little bit easier to see. And it helps if you spell kubectl correctly. Okay, and you can use also another command line tool called OC. I just tend to use kubectl because it works for everybody there. But let's do this, okay? Let's actually upgrade version 2 here to a second replica, meaning another version of version 2 running on another computer in its own little pod. And you can see when it goes 2 by 2, it'll be added to the load balancer here, and you'll see 2 versions of version 2 and 1 of v1. And again, everything I'm showing you so far is standard Kubernetes stuff, right? This is just out-of-the-box Kubernetes you get from any Kubernetes distribution. You can kind of see now it's doing 2 by 2. But that concept of being elastic, scale out, scale back, all you got to do is say you want it, okay? All you got to do is declare it. If I do an OC edit, let's see, deployment, recommendation, just try kubectl, get deployments. What did I name that deployment? Oh, recommendation v2, that's right. Slightly different name. Edit, deployment. Again, it's a declarative state, right? You have this concept of deployment. I don't want 2 replicas anymore. I want 1 now. Let's just scale back. I don't need that extra resource. You'll see that it'll start terminating that second one, and then you'll notice it also drops out of the load balancer, and we're back to a smaller set of resources if that's what we want. But that concept of the declarative deployment is a key part of how Kubernetes works, okay? You can see it now. It removed that second pod, and we're back down to a nice, normal, simple little environment, okay? Okay, so let's jump back in here. So think about all these things as you go through your microservices architecture. What is my pipeline going to be? What's my resiliency strategy going to be? My authentication mechanism, authorization mechanism, logging, tracing, and of course, performance monitoring and metrics. All these things matter when you want to deploy this highly distributed, microservice architecture with a network in between all my components. You got to think about these things. Okay? Now, I'll just go ahead and kind of level set one thing real quickly. I get this question a lot, so I feel like I have to know Kubernetes because I know Docker already, and I want to learn Kubernetes to run my Docker at scale, right? Everybody has to know Kubernetes, and that's not entirely true. If you're dealing with a single large application that you're pretty proud of, and you've been dealing with it now for many, many years, right? We have our ear file that we deploy every 3 months like clockwork. Our development team, every 3 months, we deploy. Well, if all you have is one app, and a team that's dealing with that one application, and you deploy every 3 months, and the business is super happy about that, then just keep doing that. You don't need all this fancy technology to deal with that sort of application, okay? This is where you're trying to figure out how we take our big application and split it up into smaller components so that we don't deploy once every 3 months. We deploy one of those components maybe as fast as every 3 weeks, or maybe at every 1 week interval. Or if you're in the Silicon Valley world, right, we deploy every day. As a matter of fact, what we'll see in this presentation is I can deploy every day on Tuesday at 10 a.m. during the middle of the workday. That's the ultimate goal, right? We want to be able to deploy this thing constantly in the middle of everyone using it. And that's where we see this kind of technology really helping you out when it comes to giving that kind of complex capability. So there's a bunch of stuff that's been happening in the microservices ecosystem. You can kind of see here, I actually go back in time to 1999 and continuous integration by the XP folks, Extreme Programming, and of course the Agile Manifesto back in 2001, the cloud being born in 2006. Netflix being born, Netflix moving to AWS in 2010 was a notable time and the history there as well. You can see Dropwizard and Vertex showed us how to do these concepts of fat jars back in 2011. Netflix, of course, open sources its distributed middleware that they created to be cloud native, right, back in 2012. Microservices shows up on the radar in 2012. And then really the perfect storm is right here, where Docker was born in 2013, microservices officially defined in 2014, and you can kind of see that Spring Boot and Kubernetes were born in that same time window. That's what created all this hoopla and excitement around microservices. Okay? So let's do that. Go here. Okay? Now here's the cool thing about a microservice, though. In the case of Netflix architecture, they basically bundled all this into your JVM-based application. So if you are a Java developer, you just get a new jar file for your POM XML, you slide it right in there, and you have this new capability. You want service discovery? Boom, jar file for that, called Eureka, right? If you want service load balancing, Ribbon. If you want service circuit breaking, that's Hystrix. So you got all these things if you're a Netflix follower, or let's say a Spring Boot plus Spring Cloud follower. You just had an annotation for those things. So that's the good news. The bad news is you now have all this stuff living inside your application. And that might not be what you want, okay? Also, the other bad news is it was Java only. It was a Java only ecosystem, and it only worked for JVM-based applications. If you're a Node person, a Python person, if you're a PHP or Go person, you just couldn't play along. Now, the Netflix team is working on Node.js libraries for some of this stuff too. But the good news here is that you can eliminate many of these kind of key things that would otherwise go in your jar file and pull them into the actual infrastructure. So with things like Kubernetes, right, you can see where Kubernetes augments this circle. You can see where OpenShift further augments it, right? OpenShift being Red Hat's distribution of Kubernetes. And then, of course, we can get to this thing called Istio, which is why we're all here today. Am I still moving too slow? You can say yes, right? Okay? So let's actually kind of jump into where you kind of see how Istio augments my circle here. Istio basically helps me with the service discovery. It helps me with service resiliency. It has monitoring and tracing and authentication mechanisms built in. Now, the API itself, you're responsible for. You, the programming team, are going to build your next application service, right, with your own custom API, with your definition of that. That's your code. But everything else, hopefully, can be handled by the platform. So before Istio, it looked like this. After Istio, it looks like this. You guys see the difference there? Okay, discovery, load balancing, resiliency, metric tracing, and afterwards we have this sidecar container, and that's what I was showing you earlier with the 2x2, right, 2/2. So now we don't have to worry about some of this stuff because it's handled at the infrastructure level, and that's how this particular technology works. The sidecar, which is basically manipulating IP tables, is going to intercept all traffic in and out of your application, and then they can apply these rules at the network level, not necessarily at the code level. You can still add all the stuff you want to your code. You can still use Hystrix in your code. You can still use Ribbon in your code. But now we're going to apply this at the network level, okay, the infrastructure level. So if you look at it from this perspective, right, we don't need Eureka, we don't need Ribbon, we don't need the config server, we don't need Zool or Hystrix. We don't have to have those things any longer to build a cool little microservice application, okay? And the good news is there is it works across Node.js and pretty much anything. It doesn't have to be a Java-based thing. So let's kind of show you this thing a little bit further. Get a little bit further into this. Okay? So let's have a little fun with it. If I have my little application over here, it's still chewing away. So as I mentioned, you get some stuff right out of the box. All right? So I have Istio running back here as a series of pods. So Istio itself is deployed as a series of pods, like most things in Kubernetes land. I get the monitoring out of the box here. You can kind of see that I have 100% success rates, no 500 responses from the, in this case, you can see it's the tutorial namespace with the customer application. I can also drill down on recommendation and preference if I want to. I can also see the tracing of these guys. So I can kind of come in here and say, well, what is taking so long in the application? Which thing is taking the most amount of time? Is it the recommendation application component? Is the preference component? I can look at those traces throughout the application. And then we have another thing we've been working on called the Kiali solution, which is a replacement for the service graph, which comes from the upstream Istio tutorial, right? Sorry, Istio upstream. We've committed this now to the upstream, and I can do things like, what are these transactions? What do they look like? So I can kind of see how things are flowing. You see it goes back and forth between 1 and 2 kind of thing. So that's exactly what's happening inside our application. And so that's what it looks like. But let's have a little fun with it now, okay? This is, again, so far, standard Kubernetes behavior. Nothing unusual so far, other than all that monitoring and metric tracing and stuff I kind of get out of the box now, as opposed to having to add that to my code. But let's do this. Let's come in here and say, let's make everybody point to version 1. Uh-oh, and I got an error here. Because of the cryptographic error, it's the Kubernetes local certificate. That's interesting. So hold on. Let's see if we can fix this real quick. So let me make sure that I am logged in correctly. Sometimes I get not logged in. Okay, and there's actually a little bit of, I'm having a problem with this particular environment. It is time definitely to recycle this virtual machine. This is a VM running right here. You can kind of see running with 10 gigs of RAM and 4 processors. Okay, so that's how I'm running this whole cloud locally. And let's try this one more time. Let's see if that fixes it. Nope, still going to have that certificate error. Let's see here. Let's go to this script and figure out exactly what it is that I'm trying to apply. Okay, and all we're doing is Istio create, so that should work, right? That is pretty straightforward stuff. But you can kind of see what it's doing here. It's basically trying to apply these two things called the destination rule and a virtual service. And what that allows me to do is apply a certain set of rules to the Istio proxy, as I mentioned earlier, to the sidecar. But if I have a pilot validation issue, posting on Gallon, and why is that giving me an error? Timeout, X509 certificate. I'm trying to think, at what point did I change that so it actually has a certificate issue? Let's see here if all of these things are going to fail on me. Let's see here. Clean. I'm looking at some of the more interesting ones. Okay. So I'm curious to see here. Yeah, right, exactly. Those things don't exist. Okay. Dark launch. And, okay, that one applies, but not quite working as I would like it to. And that's because the destination rule is not set yet. So destination, okay. And actually, it's not spelled destination rule. Cube, cuddle, get, CRDs. So this is all implemented as a set of CRDs, okay? So if you're familiar with Istio, again, this is kind of an advanced thing. I basically have, if you're familiar with Kubernetes, the concept of the custom resource definition. You can always extend Kubernetes with your own object types, and that's basically what's happened here. So you kind of see there's RBAC configs and quotas, and then we have this concept of destination rules. And let's see, destination. Okay, destination rules. And QB cuddle, get destination rules. Yep, I don't have any of those created at this point. And so let's see here. Let's see if we can clean this up. Dun, dun, dun. We got the mirror. Yeah, we don't want that mirror at this point. And we're going to have to, let's see here. Let's see if we can figure out why this guy's misbehaving. So basically, it's just simply this script, right? You can see it's using this thing called istioctl and a create, and this this thing called destination rule recommendation. Let's kind of show you what that looks like real quick. Okay, so here's all these files. Destination rule recommendation v1. That's what that one is. Okay, you can kind of see basically it's saying I have a version 1 and a version 2. And then if I come over here and say I want version 1 and version 2, I think that's that one. You can see where it says v1 and v2. Okay, and that's all I'm trying to do is apply that particular one. So istioctl create -f. And if you're familiar with Kubernetes, the create -f, apply -f is the standard pattern that you're always using. Okay, so recommendation and v1, v2. There we go. All right, I'm still going to get this pilot validation, Istio post validation. Timeout on that component. So the only thing I think, we don't have a lot of time for debugging purposes, but let's see if we can just basically fix something real quick. I wonder if this thing has been up too long and I've had some problem with it. I'm just going to restart pilot. And just so you know where this pilot thing comes in is right here. Okay? The concept of pilot is basically one of the core components of Istio, along with Mixer and along with Citadel. These three components basically make up the control plane for interacting with all these Envoy sidecars. You can always just use Envoy straight up and just simply handle all the envoys you have running out there. But if you have 100 of them or 1,000 of them running, because you have all these different pods, then you have to manage them all individually. And the concept of Istio Pilot is you can manage them en masse. Let's see here. OK, I'm going to have to go back and deal with that X509 certificate, because that's a new issue for me. So no easy way to fix that one, I don't think, without reinstalling the environment. And I have to figure out exactly what went wrong there. Come on. Come on, Pilot. See if you'll come back to life for me here. OK, yep, it's back online now. And then the Citadel. Yeah, that one's that one. I'm just going to restart it as well, just to see. Yep, go back up. And let's make sure, let's just restart some of these components. So this is the back end of Istio that I'm basically interacting with here, and see if I can hack it back in some, world that it actually wants to behave correctly in. I don't have this particular application running on one of those other clouds, so therefore it's not going to work from that perspective. Yeah, I'm going to have to figure out how to get around that particular X509 error. And I'm not sure exactly what I changed in that particular demo to make that work, or break, actually. OK, well, let's just jump back into slideware mode. OK, so just look for these components, Pilot, Istio, Pilot, Mixer, Citadel. And again, look for that sidecar. That's the element that you'll see there. If I look at the sidecar here, you can see cube, cuddle, get, pods. Again, that's the 2x2. If we actually inspect our deployment, cube, cuddle, describe, deployment, customer. Okay, you can kind of see when we describe our deployment that this component was added to it. Specifically, you can kind of see where it's making the invocation. There's the Envoy. There's the Istio proxy. So this is the component that was added. Okay, this was not something that, if you look at the original code for this application, was in there. The only thing that was in the original code is simply the image customer. Okay, so with that, if you have the thing working, which mine's not working right now, you can do things like a blue-green deployment, and that's actually very straightforward. It's actually very easy to do a blue-green deployment in the case of Kubernetes, because that's just something that's part of it. And the nice thing about a blue-green deployment is if something fails, it's easy to fail over and go back. Okay? Also, there's this concept of the canary deployment. And again, a small change moving to production. And then as you basically decide that that canary is working well, you can grow it over time. Have you guys heard the phrase canary in the coal mine before? Okay, so this concept applies here too, and you can decide exactly how to roll that thing out to more and more users as you go. So in this case, you can kind of see I have another rule here. Let's go to this one here. Okay, and let's see here. If I look at my Safari one as an example, you can kind of see that we can also basically decide who gets to see what version of your pod. In this case, version 2, based on the fact that they come from a Safari browser. Or you can decide that they have to be logged in. Or any HTTP header that applies to you. Are they a beta user that's logged into the application who's using Safari on iOS? Then they get access to the new Canary deployed pod that you have. So that concept of actually having a Canary is incredibly powerful in this new world. You can do Canary deployments with regular Kubernetes, but this particular one is very finely grained. You can really kind of dig in there and see how it works. OK? And let's kind of go here. So by default, round robin load balancing you get out of the box for free with Kubernetes. That's the kind of the tricky part. But with Istio, you can basically slice and dice it very finely. I want 1% of my users to go to the new version. You also have, this is just a funny thing someone gave me. There's a Canary resuscitator, which is kind of cool. And then the Istio demo that I'm referring to here, the one that just doesn't want to work for me right now, is all at this bit.ly link. You can kind of come over here and basically run through this entire GitHub repo and then work yourself through all these examples. You can see there's customer preference and recommendation. There's a lot of other aspects to this. And if I drill down over here, you can kind of see there's the concept of how to deploy these microservices, how to get the monitoring and tracing. That's the stuff we were looking at over here. All right, over here, these guys running. Okay? And then, of course, you have your simple routing, your advanced routing. You can also do things like fault injection. Basically, you can throw 503s and network delays into the application, circuit breaking, how to do pool ejection, how to fail fast, and things of that nature. And then there's even some advanced stuff we've been working on, like mutual TLS between the services, service virtualization, authentication via a web token, as an example, and RBAC. So all of that is part of this tutorial that I mentioned earlier that you can spend many, many hours checking out. If you're not interested in trying to install it all, there's also learn.openshift.com/service-mesh, where you can basically just use something up in the sky, meaning, let's do this. I can basically just say, start a virtual machine, and this is actually going to launch for me an environment where I can use it in the cloud without having to install everything locally. And you can kind of see exactly how it's taking a little bit of time here to load. But this is basically launching a virtual machine for me with everything installed, and you don't have to install things on your laptop, okay, like I have here. So that is another way to kind of get started quickly. All right, and it looks like we're out of time. A couple other things to be aware of for the presentation. There's a bunch of other links inside the presentation, the Istio-intro presentation, including some free ebooks that we have from Red Hat you can download for like microservices, building reactive microservices, a bunch of other things, like, for instance, I mentioned the service mesh one and the tutorial, but there's also things for function as a service. There's also a great book here from Etsu Yanaga. He came and presented to you guys last year. So he works with me, a colleague of mine, and so you can deal with your relational monolithic app database in a microservices world. And of course, you can also think about a book that Christian and I have been working on for Istio in particular. The Istio book, though, is based on the upstream of that Istio tutorial I was showing you earlier, right? This guy here, okay? And it's also the same thing that you see here. So all these things are essentially one and the same. This guy, and of course, the book, meaning it's a little bit older now, because the book, of course, has to get printed. So that is all that I have, and we are certainly out of time at this point. But do you have any specific questions for me? Yes, sir. Yep. That was way back when. All right, here, this guy. And so specifically the tweet was, right, you had to get this, Øredev. Okay. And actually, let's try this real quick. Dun, 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 dun. All right, Dev. Okay, so what we're going to do is we're going to pull one of these folks out of here. Let's see, you guys. It looks like some of you folks have done something here. Okay, fantastic. All right, so let's go. We're going to go. This is going to be our winner. We're going to let it pick one. All right, you guys ready? And it's this one. Let's see. Fantastic. There we go. So is this person here? All right, that'll be our winner for our Chromebook. Any other questions besides what to tweet on? And I'll be available after the session to answer any more questions you guys might have. But are there questions you want to throw at me right now? No? Yep, so that's a good point about overhead. So this thing, again, is intercepting all network traffic in and out of every pod. So there is a percentage of overhead that you're going to pay in network latency on top of that. So they're constantly working to make that smaller, but right now it is a little bit it is a little bit large, if you know what I mean. So if you're going to be doing like 1 billion transactions per second, you probably don't want to use something of this nature. If you're simply building a little simple application that's basically like a normal business application, then it probably will handle that load without a problem. So Istio at this point in time is not quite ready for production the way Red Hat thinks of it. So we're making it ready for production for the Red Hat customer base. So it still has to mature. And you'll notice that things are changing rather rapidly in this space. And then I was just basically, let's do this. And I was just seeing exactly if this virtual environment will run for me here. And build. And let's see, so the same thing you saw me doing earlier. Let's get that running. See if that pod is coming up. Okay. So let's run my little curl command. So there it is. That's the version 1. Okay, I didn't make a change to that one yet. But this is the exact same thing I was running on my local machine. And you can kind of see it running here. So the same thing we had earlier. And here. And continue. And then, all right. So if you notice, there's actually 2 different pods here. Do you see that? They both say version 1, but they're 2 different pods. And if I come over here and run those scripts there, notice it's all version 1 now. Okay, the original version 1, the original pod. So the same thing that I was running for you on the local machine that didn't want to work for me, you can, again, run all these things in a public cloud hosted VM. Okay? So that's the nice thing is you don't have to worry about installing everything you saw me running here, including the 10 gigs of RAM with the 4 cores that I have running. That's actually a lot. So this is a 32 gig machine with 6 cores, so therefore I can run a whole cloud pretty much locally. While you guys are, no one wants to jump up real quick. Let me show you one other thing that's kind of fun. Okay? I do have this whole environment running across different clouds. Let's see if this will work for me. You guys pull out your phone. Let's draw a picture, because the nice thing about all this is you guys can draw pictures. So Bitly Cloud Paint, try that one. It gets you to this user interface here. Okay? And you can draw pictures with me. So I just have everything running in the public cloud. So let's go here. Oh, there's someone who's already drawing. Okay. And here. I have a more interesting version of something like this for tomorrow's presentation. But see, I'm drawing pictures. You guys are drawing a picture. And for every stroke that you put in your HTML5 canvas, basically it's reflected through a WebSocket and out back through my cloud-hosted service, and then, of course, into this little dashboard here. But that concept of being able to build an application and easily deploy it into any kind of cloud environment is really the whole point of this whole Kubernetes thing. OK? All right. Well, any other questions? If not, I can definitely take questions after the session. Yes, sir?
Rolling updates.
Yep. So the nice thing about rolling updates, and the question is rolling updates, you get that for free with regular Kubernetes, right? So you don't have to worry about that at all. You get a blue-green, and you get a blue-green deployment as well in Kubernetes. That's just stuff that's really simple, and it's part of the architecture. The one key tip to remember is that you need to be looking out for your liveness probe and readiness probe. If those aren't set correctly, then you don't want to attempt a rolling update or even a blue-green or a canary deployment or anything fancier than that. But otherwise, they work beautifully. Okay, and that's what people are using all the time within that was the original thing people, the Kubernetes showed the world was how to do a rolling update. Okay, and all you got to basically do is just simply change the image name. If I come back over here, let's see here. Okay, so all you got to do is actually just change the deployment. Edit deployment, and you know, if you just change the deployment to on this image name, where's my image name? I'm going to go actually make this v1. All right. And notice it's all set to v1. So that stuff is dead easy in Kubernetes land. So where's our winner? Was it Dominic? Was that the name? Where'd it go? Oh, not that one. I lost the person. Here we go. This person right here. That was our winner for our Chromebook.